everyone, today I will be measuring the height of the safety net in my neighborhood park. Obviously, I can't use a tape measure to measure the height, but no worries because we can use a clinometer for the angle reading and some calculations using the angle of elevation. The angle of elevation is an angle formed by the horizontal line and the top of the object from the view of the observer's eyes, while a clinometer is a measurement tool used to measure the angle of elevation. The angle of elevation from the clinometer is related to the angle reading because the angle of elevation is dependent on the angle reading. The angle reading of the clinometer and the angle of elevation are both formed with a horizontal line and view from the observer's eyes to the top of the object. To calculate the angle of elevation using the angle from the angle reading, we can use 90 degrees subtracted by the angle reading. Here I am using the clinometer to get the angle reading of the top of the safety net. Then I also measured the distance between the safety net and myself, with some help. I gathered measurements from the two distances which ended up like this. Now that we have the angle reading from the clinometer and also the distance between the safety net and me, we can calculate the height of the safety net using trigonometric ratios. Before that, let's assess which trigonometric ratio to use. There are three common trigonometric ratios which can be remembered using SOHCAHTLA. The first trigonometric ratio is sine, which is opposite over hypotenuse, then cosine, which is adjacent over hypotenuse, then lastly tangent, which is opposite over adjacent. Since the distance from the safety net to me is adjacent to the angle of elevation, we will be using tangent. Moreover, the unknown height of the safety net is opposite to the angle of elevation. Now we should first calculate the angle of elevation, which is 90 degrees minus the angle reading. For the first distance, the angle of elevation is 90 degrees minus 50 degrees, which is 40 degrees. Then we input the angle of elevation and the distance into the tangent formula. Tangent 40 is equal to x over 5.4. X is now tangent 40 multiplied by 5.4, which is equal to 4.5. But it doesn't end there. The height of my eyes to the ground is 1.5 meters. 4.5 plus 1.5 is 6 meters. The height for distance 1 is 6 meters. Now applying the same routine to the second distance gives us a height of 5.4 meters. Though, measurements using a clinometer might not always be accurate. Some factors causing this are human error, for example incorrect measurements when measuring distance between object and observer, misreading the angle of reading, lack of concentration, and the such. Second is instrumental error, for example flawed measurement tool, uneven ground or sloped ground, and so on. Both of my calculations differ in result due to the second factor of instrumental error. The ground of the basketball field is sloped, which is why when I get further from the object the height decreases and when I get closer the height increases. I actually went back and forth measuring and calculating the height of the safety net before realizing the ground was sloped. The difference of the calculated heights is about 60 centimeters, which means the height of the ground is about 60 centimeters in difference. Other than for measuring safety nets, clinometers can also be used to measure other objects which are too tall and are too much of an inconvenience when measured using a tape measure. For example, the height of a building. Clinometers can also be used to measure the slope of a building and even make sure the height of houses in the neighborhood are the same height. In meteorology, clinometers are even used to measure the height of a cloud. That's all. Thank you.